So I'm in San Jose today for another reason, and we drove up this hill over the valley, so to speak, and we noticed that there's this outcropping of rock that was green over here, and I know from geology that we have a lot of California serpentine outcroppings in this area. So ended up in this parking lot over here, and as you can see, this is all pretty low quality serpentine, but this whole hill that we're on is made out of this serpentine rock. And it makes for pretty interesting geology. I can't get around the bend to see that whole big outcropping, but underneath this hill over here is all just this rock. And so they just kind of left it in place. Geology just pops up. Over to the USGS map view website, you can find the maps that show your area. This one is courtesy of the Dibley Geological Foundation. So USGS just collects a lot of these maps. This may have been done for commercial reasons, maybe a construction company or something like that. I don't really know what the Dibley Geological Foundation is. These maps are wonderful because you can find where you are. It shows you the roads and everything. So where we were when I was looking at that serpentine was this area, this blue area called SP right here on the map. We were kind of just right on this hill facing southwest over here. So we find SP in our legend. Here it is. Serpentinite, hydrothermically metamorphosed from ultramafic igneous rocks such as dunite and diabase, blue-green gray amorphous hydrous magnesium silicate with specks of magnetite, much fractured and silicated. So magnesium silicate, right? So the magnesium is what give it that green color, and the silicate is what it makes it smooth. And the specks of magnetite, which are a lot of iron in it, that makes it black. So if you remove all the iron, if it gets hot enough in that metamorphized ultramafic igneous rocks, a lot of times you end up with bits of jade. So there's a lot of jade in California as well, but it's all low quality because it has so much iron. But all this is to say that it is metamorphic rock. The surrounding green area over here is mudstone. So it's dark gray, micaceous, includes a few of the areas of fine-grained gray wax sandstone. So this is old mud flows from volcanic ash, all that sort of stuff. And so this blue ribbon right here turned metamorphized into serpentinite, and this stuff up here was mudstone. And then this little band in the middle is just a creek. So sometimes you can find fun little pieces even when you're not out rock hunting officially. So don't tell anybody, but I picked up a piece of that serpentine that was kind of on the side of that sidewalk. I figured it was just kind of garden material at that point. So if you look at it closely, there's a lot of nice green material in there. So I am going to, let's see. So I'm not going to create a cap out of this or anything like that. I'm just going to polish one side, flatten it out, polish it, just so we can get a sense of what this material would look like. And it's a silicate. It should polish up nice in this area right here that has a lot of the green. So if we flip it on and grind, I'll show you the end result. Otherwise, it's just a bunch of noise, and you've seen all this before. So a quick couple minutes grinding, and I got, this one side fairly flat. Nice greens and yellows in it, nice pattern and stuff. I'm going to polish this up so you can see it a little bit better. So it has potential. I call it low grade because there's so few parts of it that actually will take a good polish, and there's so much of it that's just kind of this black color. I like that. It's a nice little piece for my sample collection.